Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 6, improving product quality and reducing defects. Defects don't just cost money, they cost reputation, customers, and future growth. In this episode, we explore how vision systems, IoT monitoring, and real-time data can dramatically reduce errors and improve product quality where it matters most, on the shop floor. You'll hear how companies in electronics, plastics, and automotive have slashed warranty claims, cut defect rates, and built better products with smarter processes. We'll also dive into how DBR77 helps identify root causes, simulate process changes, and provide early warnings, all before customers ever see a problem. Factory on Air is powered by DBR77, the AI-first platform for automated quality control, digital twins, and data-driven manufacturing. Let's get started.
Welcome to the deep dive. Imagine, if you will, the seemingly tiny cost of just one little imperfection in a product. It's easy to think, oh, it's just a hiccup, maybe a few cents lost on a faulty part or, the minor hassle of a customer return. But what if that tiny flaw, that one small error, when multiplied across thousands, maybe millions of units, actually unleashes this huge wave of hidden costs? Costs that, they ripple right through an entire company, damaging a hard-won reputation, eroding that customer trust that takes years, decades sometimes, to build. And it can even hit the morale of the teams on the factory floor, the very people trying their best to make things perfectly. Today, we're not just glancing at the quick fix. We're diving deep into the true, often invisible costs of imperfection in manufacturing. And maybe more importantly, we're going to explore how cutting-edge modern technology is stepping up, not just to patch things up, but to drastically slash defects and really revolutionize product quality.
It really is a fascinating turning point, isn't it? The consequences of what might seem like minor quality slip-ups can, as you said, just cascade. They ripple through the whole organization, hitting everything from the financial statements right through to how a brand is seen globally. We're definitely seeing a major shift now where getting close to perfection isn't just some lofty goal anymore. It's becoming an achievable, data-driven reality, at least for manufacturers who are willing to embrace these new technologies.
Exactly. And that's really the heart of our deep dive today. Our mission here is to unpack the critical role, really game-changing role of advanced tech. We're talking about things like intelligent vision systems, the Internet of Things, connecting everything, and the predictor power of artificial intelligence, how they're transforming quality control. It's moving away from that reactive scramble, fixing problems after they happen, towards being a proactive powerhouse that actually prevents them in the first place. So we're going to really dig into the tangible impact, often painful impact, that defective products have. Direct money hits, sure, but also that slow burn of eroding trust. And then we'll look at how a comprehensive digital platform, something like DBR77, is tackling these challenges head-on, offering a clear path not just to operational excellence, but a real lasting competitive edge in today's market. It's tough out there.
Right. And for this discussion, we're drawing insights from, basically two key areas. First, a detailed analysis that focuses specifically on improving product quality and, crucially, reducing manufacturing defects. And we're going to intertwine those findings with a comprehensive overview of a specific digital transformation platform, DBR77 in this case. By weaving these two perspectives together, the aim is to give you a really holistic picture, how these advanced solutions are shaking up manufacturing right from the ground up.
Okay, let's unpack this then. The financial hit from a faulty product, that seems obvious, right? Money lost. But the long-term damage to a brand's reputation, even to the spirit of the team inside the company, that's where it gets really interesting, I think, where that ripple turns into a tidal wave. So when we talk about the high cost of imperfection, it's way more than just the immediate numbers on a spreadsheet. Let's start with those direct financial drains, ones you feel straight away. A product comes off the line, it's faulty. What happens right then?
Well, the most immediate thing is usually product returns.
Right.
And each return isn't just, a lost sale. It's often a double whammy. You've got costs for shipping it back, handling it, processing the return, all on top of the revenue you already lost.
Right.
Then you have customer complaints or reklamaki, as you might hear in, say, Poland or other parts of Europe.
Mm-hmm.
These aren't just annoying emails. They chew up serious staff time and resources. Think about customer service teams, hours on the phone, paperwork, arranging replacements.
Yeah, that adds up fast.
And then, inevitably, these problems often mean you have to actually remanufacture the product completely, or at the very least do significant rework. And that means more labor, more raw materials, more machine time used up. up. These are, undeniable hits, tangible costs to the company's health, and they can stack up incredibly quickly, sometimes turning what looked like a tiny flaw into a huge hole in the budget. It can even cost more than making the original item in the first place.
So it's not just the sale you lost, but all the downstream costs of just fixing that one mistake. That's a pretty heavy burden. But you mentioned something deeper, the indirect, the long-term damage. You said these small defects create a cascading effect, leading to hidden costs far beyond the immediate fix. Let's talk about that erosion of trust and brand image. That sounds devastating.
Oh, it absolutely is. Think about it. If customers keep getting faulty products from one company, their trust in that brand doesn't just dip, it can completely evaporate.
Yeah.
And this isn't just about losing one customer here or there. It tarnishes the brand's image across the entire market, makes it way less attractive to potential new customers. Imagine trying to stand out in a crowded marketplace when your name is linked with unreliability. It's tough.
Really tough.
This long-term hit is super hard to put an exact dollar figure on immediately, but over time, it can cripple a company's market standing and future growth prospects. It's like a slow bleed, often much more damaging than a single big financial loss.
And it doesn't stop at the customer, does it? You mentioned those bureaucratic burdens, often overlooked. Tell us about the recertification headaches. What's involved there?
Ah, yes, that's a really critical point. If you have a batch of products that fails quality checks, or worse, needs major rework because of widespread flaws, you often have to go through this whole painful process of recertifying them.
Oh, right.
Especially in regulated industries, think automotive, aerospace, medical devices. It's mandatory. It means proving all over again that these products meet all the required standards, even after they failed the first time.
Sounds like a nightmare.
It's a huge bureaucratic load. Endless paperwork, new inspections, maybe even external audits. It causes significant delays, pushing back launches, holding up shipments, and of course it piles on extra costs for all that testing and admin overhead. It's like having to retake a final exam you already failed, but with much higher stakes.
And if your reputation is taking a knock and you're stuck in recertification limbo, that must hammer your market position too.
Directly, yeah. It leads straight to a decline in market share and real challenges in acquiring new customers. If word gets out that your quality is shaky, new buyers are naturally going to hesitate, aren't they? They'll look at competitors, even if your sales team offers a great deal.
Makes sense.
So your sales and marketing costs actually go up because you have to work so much harder, spend so much more just to overcome that negative perception and convince people to give you a chance. It becomes this vicious cycle where poor quality actively hinders your growth. Your marketing budget shifts from showcasing innovation to just damage control, trying to rebuild trust.
And then there's the human cost, the impact on the team. I feel like this often gets lost in the numbers and the market share charts. What does all this constant firefighting, this rework, these customer complaints, what does it actually do to the people on the ground? Their morale?
It's a critical fallout, and yes, frequently overlooked. Just imagine you're a dedicated engineer or a skilled worker on the line, or a careful quality controller, and you're constantly dealing with defective products, endless rework cycles, maybe angry customer feedback. It can be incredibly demoralizing.
I can imagine.
It leads to frustration, definitely burnout, sometimes a feeling of just futility among the very people you rely on to create the products. Nobody enjoys feeling like their hard work consistently results in flaws, and this hits productivity, of course. Teams spend valuable time fixing problems instead of innovating or improving things or doing higher value work.
Right.
It impacts job satisfaction too. You see higher turnover rates. It becomes harder to attract good people. So yeah, quality issues aren't just technical or financial problems. They're deeply human ones, hitting the very core of your workforce.
That's a really powerful reminder. The human cost.
Ah.
It can be huge.
Okay, so given these massive, multi-layered costs of imperfection, how are companies fighting back? How are they trying to stamp out these defects before they snowball? One of the most exciting technologies stepping up here, literally giving eyes to the factory floor, are these advanced vision systems. So for those listeners who might not be deeply familiar, what exactly are vision systems? How do they work your magic?
Okay, so vision systems are essentially these really sophisticated setups. Think of them as tireless, super perceptive eyes right there on the production line. At their heart, you've got high-resolution cameras, often combined with specialized lighting. This isn't just any lighting. It's designed to perfectly highlight specific features or potential defects. Sometimes they even use infrared or UV light to see things the human eye just can't.
And then the crucial part is the advanced software. That's the brain. It analyzes the images coming from the cameras in real time, It performs complex calculations, compares the image to a golden standard of what's perfect, and it does this way faster and much, much more consistently than any human inspector ever could. They're programmed with exact parameters, what's acceptable, what's not, and they flag anything that deviates instantly.
That level of precision,
Yeah.
it just opens up amazing possibilities, doesn't it?
Yeah.
We're not constrained by human eyesight anymore. So what specific kinds of hidden flaws, those things that often slip through the cracks, are these super eyes now catching?
Oh, they excel at detecting a huge range of defects, many that would be almost impossible for a person to reliably spot, especially at high speeds. For instance, tiny surface flaws. Think hairline cracks, microscopic scratches, maybe subtle warping or deformities that could signal a problem with the raw material or the molding process.
Things you'd easily miss.
Absolutely. They're also brilliant at spotting assembly errors, making sure every single component is placed correctly, nothing's missing, everything's aligned just right, whether it's a tiny screw or a complex circuit board. Beyond that, vision systems are vital for checking dimensional deviations, ensuring products meet exact specifications down to fractions of a millimeter, sometimes even micrometers, super critical in fields like medical devices or aerospace.
Precision is everything there.
Exactly. And they handle aesthetic issues, too, like catching the wrong color shade, misaligned labels, smeared printing, incorrect markings. All things that might not affect function directly, but can seriously impact how the product is perceived, brand integrity, and sometimes even regulatory compliance.
So it really is about going far beyond what humans are capable of. You're saying they catch flaws we simply can't see, or at least not reliably at scale. Can you give us a concrete example? Something so subtle, only a machine could reliably detect it at speed.
Sure. Imagine a pharmaceutical company making millions of tiny pills every day. A human inspector just physically cannot verify the exact coating thickness, or check for microscopic contaminants, or ensure perfect uniformity on every single pill flying down the line. It's impossible. But a vision system, it can use high magnification cameras, maybe specialized lighting techniques, to spot a tiny sub-millimeter impurity, or a slight color variation that indicates the chemical mix isn't quite right, or even micro cracks in the pill's coating that you'd never see but could affect how it dissolves or its shelf life.
Wow.
These flaws are often totally invisible to our eyes or easily missed due to fatigue during manual checks, yet they can have huge implications for safety and effectiveness. The sheer volume and speed make manual inspection completely inadequate for that level of quality assurance.
Right. If we connect this back to the bigger picture, then, it's really about that shift, isn't it? Moving from reactive quality control, finding problems after they've happened, to genuinely proactive defect prevention. All thanks to this incredibly detailed real-time data. And it's not just about what the product looks like when it rolls off the line, is it? There's also the crucial role of monitoring the production conditions themselves. It sounds like the manufacturing environment itself can be a kind of hidden saboteur, quietly messing with quality.
Precisely. And this brings up a really important question. Are we just inspecting the final product? Or are we actively managing the environment that creates that product? The impact of the environment on quality is huge and, yeah, often underestimated. Things like the ambient temperature in the factory, the humidity levels, the air pressure, even tiny vibrations from nearby machines. All these can significantly influence the final product quality during the manufacturing process.
Can you give an example?
Sure, think about assembling delicate electronics in a clean room. Even tiny fluctuations in temperature or humidity can cause static electricity issues or affect how materials bond, leading to hidden defects that might only show up later, causing failure. Or in fields like metallurgy or chemical production, you need incredibly precise temperature and pressure control. Slight deviations there can literally change the molecular structure or the purity of what you're making.
So it's about creating this, perfect climate for production. How does constantly monitoring these things in real time help maintain that stability and stop these environmental factors from causing quality problems?
Well, continuous real-time monitoring is absolutely key for that stability. By deploying a whole network of IoT sensors, Internet of Things sensors throughout the facility, and not just on the machines, but in the surrounding environment too, manufacturers can ensure conditions stay within the ideal preset ranges throughout the entire process. These sensors are constantly feeding back data temperature, humidity, pressure, vibration levels, you name it. This constant stream of accurate data provides immediate feedback to control systems or to human operators, allowing for tiny, rapid adjustments to keep everything stable. It's really about creating a highly controlled, consistent, predictable manufacturing bubble where variations are spotted and corrected almost instantly before they get a chance to mess with the product.
And what about using this data as an early warning system? Can these environmental blips actually predict a problem before a defect even happens?
Absolutely. And this is where it gets really powerful for proactive quality control. These fluctuations often act as crucial early warning signals. They can predict potential issues long before any actual product flaws show up. Well, imagine a sudden, unexpected temperature spike inside a specific curing oven, or maybe an odd drop in pressure in a pneumatic system that powers assembly tools. These might indicate a machine starting to fail, maybe an inconsistency in the materials being fed in, or some other process anomaly. If you don't catch it, it will eventually lead to defective products down the line.
Right.
So the preventative aspect here is critical. By catching these deviations early, manufacturers can step in, maybe adjust parameters, schedule maintenance, even pause that specific process briefly. They can act before any faulty products are actually made. This saves huge amounts of waste, slashes rework time, and avoids the cost of scrapping entire batches. This granular, real-time environmental data lets us predict and prevent instead of just reacting after the damage is done.
That's fantastic. And these aren't just theoretical ideas or things coming soon. We're seeing real numbers, actual companies dramatically cutting their defect rates and costs right now. This is where it gets really interesting for me. Seeing these tangible improvements from quality-focused tech translate directly into a stronger bottom line and a real competitive advantage. Can you share a specific success story?
Definitely. Take an electronics factory, for example. They were really struggling with product consistency, getting a lot of customer complaints. So they implemented advanced vision systems at several key points on their assembly line, particularly for inspecting circuit boards and the final product casings.
And the results?
Pretty dramatic. They saw a massive 45% reduction in customer complaints.
45%. Wow.
Yeah. And that number, 45%, it represents so much more. It means a huge jump in customer satisfaction, likely more repeat business, greater loyalty. It also means far fewer returns to process, way lower costs for handling complaints and doing rework, and of course, a much stronger brand reputation in a market where, let's face it, trust is everything. Think about the relief for the customer service team and the freedom it gives the marketing folks.
That's a massive win, absolutely. What about a different sector, maybe something like packaging, where quality is also vital?
Good example. Let's look at a PET bottle manufacturer. You know, the plastic bottles for drinks and food. Their integrity is crucial for safety, obviously. They found that by carefully monitoring the forming temperature of the plastic, a really critical parameter in their molding process, they achieved a remarkable 30% decrease in the percentage of production defects.
30% just from monitoring temperature.
Exactly. Defects like bottles being deformed, having weak spots, or inconsistent wall thickness. It really highlights that direct, measurable link between controlling a specific environmental parameter during manufacturing and the quality outcome you get. It shows that understanding and managing the process conditions is just as vital as checking the final item. Even a tiny temperature drift could compromise millions of bottles.
That makes perfect sense. And the automotive industry, they're famous for intense quality and safety standards. How have they leveraged this kind of integrated approach, vision systems plus condition monitoring?
Yeah, the auto industry offers some really compelling cases of holistic quality improvement. There was one major car manufacturer. They integrated visual inspection systems for checking component assembly accuracy alongside comprehensive condition monitoring on their painting and welding robots. The result, they managed to cut their warranty costs by an impressive 20% in just 1 year.
20% reduction in warranty costs. That's huge.
It really is. Warranty costs are a direct measure of those post-sale quality problems, the defects that only show up after the car's left the factory and is with the customer. Slashing those costs by a fifth speaks volumes about the improved reliability and durability of their vehicles. It's not just massive long-term cost savings, it significantly boosts customer trust, builds loyalty, and even helps resale values. In an industry where safety and dependability are absolutely paramount.
These examples really drive it home. These aren't isolated incidents. They show a clear trend. Precise, data-driven quality control delivers tangible, measurable, significant results across all sorts of industries.
It does.
It feels increasingly clear that these technologies aren't just, nice-to-haves. They're becoming essential tools for staying competitive, maybe even for survival. Which brings us neatly to DBR77. You mentioned it earlier as a comprehensive platform, acting like a digital guardian of quality. It seems to connect all these dots we've been discussing, sensors, data, AI. How does DBR77 actually approach quality control within its broader ecosystem? How does it tie all this together?
DBR77 is engineered right from the start as a comprehensive platform. It's specifically designed to actively support and really enhance quality control by integrating data from all those different sources across the entire production and logistics chain. It operates on the principle that quality isn't just one department's job, it's a holistic result of many interconnected processes. So it's not just another standalone inspection tool, it's an interconnected system that gathers, analyzes, and crucially acts upon data from the entire operational landscape.
Okay, so it starts with that real-time data collection using the power of IoT. But lots of companies struggle just getting good, consistent data off their machines. How does DBR77 actually gather this vital info?
You're right, the foundation of any solid quality system is accurate, real-time data. And DBR77's IoT solutions are built specifically for this. They go beyond just basic monitoring to provide really granular, actionable insights. One thing that sets DBR77 apart is that they often use their own precise sensors and infrastructure. They install them directly onto individual machines, complex production lines, even throughout entire facilities.
Ah, so they control the data source.
Exactly. It helps address that fundamental challenge, ensuring the integrity of your data right from the start, from the sensor level. These smart sensors continuously monitor critical parameters, everything from temperature and pressure inside a specific machine to its operating time, how much energy it's using, even subtle vibrations.
Okay.
But it's not just about collecting piles of data. It's about getting accurate, up-to-the-minute information that you need for quick, smart decisions. The system is built for seamless integration and connectivity, making sure data flows smoothly and securely from the shop floor up to a central platform for immediate analysis without getting stuck in silos or facing delays.
And that high-quality real-time data then fuels another really fascinating capability of DBR77, simulating for perfection using digital twin technology. I mean, imagine being able to virtually test drive changes to your factory layout or processes, seeing the impact on quality, on flow, spotting bottlenecks, all before you physically move anything or change a setting on the real line. That sounds like a massive advantage. How does DBR77 pull that off?
It is a massive advantage, truly transformative. DBR77, combined with its digital twin tech, fundamentally changes how manufacturers can approach optimization and predict quality issues. It creates this dynamic virtual replica of your actual factory or logistics center. A sophisticated 3D model that's not static, it's constantly updated with that real-time data streaming in from the IoT sensors.
Oh, it's a living model.
Exactly. It accurately mirrors every production line, every machine, every movement of materials within the physical plant. It's a living, breathing digital counterpart. And the crucial part is it lets you safely test different what-if scenarios without messing up your live operations.
What kind of scenarios?
Okay, say you're thinking of moving a critical machine 10 feet over. You can simulate that in the digital twin and instantly see the precise impact on material travel times, potential new bottlenecks, maybe even predict changes in defect rates if that area has different vibration levels or air quality. You can experiment with new line settings, maybe tweak parameters like curing times or injection pressures, or even model the impact of a planned maintenance shutdown on overall output and quality. This what-if playground helps you identify quality-related bottlenecks and predict potential problems before they ever happen on the real production floor. Think of the time, material, and rework costs that saves.
That sounds incredible.
And it goes further. DBR77 integrates virtual reality, VR, and augmented reality, AR, for really realistic visualizations. So managers, engineers, they can actually immerse themselves in the simulated factory, walk around, see and interact with proposed changes in a super intuitive way. This helps catch potential errors or unforeseen consequences before you commit to any physical changes. It genuinely is like having a crystal ball for your factory operations, enabling truly proactive, data-backed decisions.
And then it gets even smarter, right? With predictive intelligence, leveraging DBR77's AI assistant. We hear so much about AI transforming industries.
Yeah.
How does this platform use AI specifically to spot inefficiencies and prevent quality problems before they start?
Right, this really gets to the core question. How do you shift from just reacting to defects to actually predicting and preventing them? The AI assistant provides that vital layer of proactive intelligence, and crucially, it learns continuously from your own unique operations. DBR77's platform automatically sifts through the enormous amounts of data pouring in from the IoT sensors and the digital twin data volumes impossible for humans to process effectively.
Yeah, information overload.
Exactly. The AI identifies subtle inefficiencies, patterns that deviate from the norm, and predicts potential failures or quality issues before they occur. Effectively, the AI assistant acts like a virtual lean manufacturing consultant, working 24/7. It provides smart, data-driven recommendations for process optimization before things go seriously wrong with quality.
Can you give an example?
Sure. Let's say it detects a gradual upward trend in the vibration signature of a particular machine or a specific environmental condition that its historical data analysis shows correlates strongly with a certain type of product defect appearing a few days later. It will flag this trend proactively and suggest corrective actions, maybe scheduling specific maintenance, adjusting operating parameters, or even recommending a look at the raw materials being used.
It's proactive.
Very. And what's really clever is that the machine learning algorithms powering the AI are constantly evolving. They learn from new data, refine their models. The system even generates synthetic data based on past patterns to help train the predictive models further, leading to increasingly accurate forecasting and more effective process optimization over time. It's designed as a continuously improving, self-optimizing system, always getting better at preventing defects.
So it's not just one tool doing one thing. It sounds like an entire ecosystem working in concert, where every bit of data feeds into this clearer, more holistic view of quality. Can you elaborate a bit on how DBR77's broader solutions, beyond just quality tools for production and logistics, also could contribute to this? It seems like it takes a whole value chain approach.
It absolutely does. Quality isn't created in a vacuum, right? So beyond the direct quality control features like the vision system integration or the AI predictions, DBR77 integrates wider solutions for overall production and logistics efficiency. And these indirectly but powerfully boost quality throughout the entire process. For instance, it includes tools for automatic process measurement. This ensures every single step from raw materials arriving through every manufacturing stage to final assembly and packing is quantified, understood, and benchmarked against optimal standards. It helps optimize material flow through the plant. This reduces bottlenecks, minimizes unnecessary handling, which can cause damage, and prevents defects that might arise just from inefficient logistics or materials sitting around too long. And it provides deep operational efficiency analysis overall. This connects back to quality by highlighting areas where process improvements, maybe reducing cycle times, improving machine uptime, will also lead to better, more consistent quality outcomes.
How does it identify those areas?
It uses powerful strategic tools integrated right into the platform, like value stream mapping VSM and dynamic process analysis. Think of VSM as creating a detailed X-ray of your entire production flow, from supplier to customer. It visually maps every step, every delay, every handoff, and crucially, highlights the points where value is added and where waste, including potential quality defects, is likely generated. And these aren't just static maps you draw once. They are dynamic tools within DBR77, constantly updated with real-time data, continuously monitoring performance, actively flagging quality bottlenecks as they emerge, and driving immediate corrective actions. So yeah, it's not just about spotting defects at the end, it's about optimizing the entire operational fabric of the company to inherently foster a culture and a reality of consistently higher quality.
The payoff from all this automated analysis, this integrated approach, sounds huge. If a manufacturer really embraces these kinds of advanced quality systems, what are the key tangible benefits they can realistically expect to see?
You know, knowledge is most valuable when you understand it and actually apply it. And these benefits, they aren't just theoretical fluff. They translate directly into a much more robust, reliable production line and ultimately consistently higher quality output. Firstly, there's that power of early trend detection. The system can spot those subtle drifts, those anomalies that signal a potential decline in quality well in advance. Sometimes days, maybe even weeks before serious defects would normally start appearing in large numbers. This allows for that proactive intervention before problems really take hold. It's a total game changer for preventative maintenance and truly proactive quality management. Think of the scrap and rework costs saved.
So you nip problems in the bud, basically, before they grow into expensive disasters. That must save a lot of resources, probably a lot of stress too.
Exactly right. Secondly, you achieve significant error reduction, often without needing to hire more quality control staff. This is the essence of working smarter, not just harder. Automated systems like vision inspection take over those repetitive, high-volume, frankly tedious tasks where human error and fatigue inevitably creep in.
Frees people up.
Precisely. It frees up your human operators, your skilled QA specialists, to focus on the more complex stuff, deeper root cause analysis, driving process improvements, strategic thinking, handling exceptions. This leads to substantial savings in labor costs, much better use of your human talent, and often a more engaged workforce doing more interesting work.
And response time. When the system does spot an issue, how quickly can a company react? Are we talking hours, minutes?
Yeah.
Faster.
The third big benefit is instantaneous response, which is absolutely critical in fast-moving manufacturing environments. Because the system uses data-driven alerts and automated communication, as soon as a deviation, an anomaly, or a potential problem is flagged, bam, immediate notifications go out to the right people. Maybe it's the line supervisor's tablet, maybe it's a maintenance technician's phone, maybe the quality engineer's dashboard.
Right.
This enables incredibly rapid corrective action. It minimizes the time that faulty products might continue being made, drastically cutting waste. It's about closing that loop between detection and resolution almost immediately. Sometimes the system can even trigger automatic adjustments to self-correct minor issues.
And finally, that consistency and objectivity you mentioned earlier, that must be a huge advantage compared to traditional human inspection, which can be subjective, right?
Indeed. The fourth key benefit is that consistent, objective monitoring. Automated systems provide continuous quality oversight 24 hours a day, 7 days a week. They don't get tired, they don't have bad days, they don't interpret standards differently from shift to shift. They are free from the delays and the subjective human biases that can, let's be honest, inevitably affect manual inspections.
Yeah, that makes sense.
This ensures absolutely consistent standards across all shifts, all production runs, all batches. You get a uniform level of quality that's incredibly difficult, maybe impossible, to achieve relying solely on humans. This translates into a more reliable, predictable process, and ultimately a more trusted product in the eyes of the customer. You basically eliminate the Monday morning versus Friday afternoon inspection variability.
It sounds incredibly powerful, almost like giving manufacturers a quality superpower. But we know digital transformation is never totally smooth sailing. There are always hurdles. Let's talk about navigating that journey. What are the typical challenges companies run into when they try to implement these advanced quality control systems? And how does a platform like DBR77 help them get over those bumps? For instance, just calibrating vision systems precisely and adapting them for every specific product. That sounds complicated.
It is. That's a very real and significant challenge. Vision systems aren't plug-and-play magic wands. To be truly effective, they need precise calibration and often quite deep customization for each product's unique shapes, materials, colors, and potential defect types. A system set up to inspect engine blocks won't just work out of the box for inspecting tiny medical vials, right? DBR77 addresses this partly through its underlying human-centric design philosophy, which aims to simplify configuration and use across the board. Now, the sources don't detail exactly how DBR77 handles vision system calibration specifically, but their overall approach emphasizes ease of use. The goal is that most functionality should be understandable and usable after just a few hours of training.
Okay, so making it less intimidating.
Exactly. That intuitive design, plus they provide extensive support materials, detailed case studies showing how others did it, their online DBR77 Academy for Learning, regular webinars. All this helps users get to grips with the concepts quickly and learn how to adapt the tools to their specific products. It lowers the learning curve dramatically and means you're less reliant on calling in expensive external experts for every little tweak or new product introduction. It empowers the internal teams.
And what about the integration headache? That sounds like a big one. Many manufacturers have these deeply embedded, sometimes ancient systems, ERP, MES, WMS. Getting a new quality platform to talk nicely to that existing infrastructure must be a nightmare sometimes.
Integration is definitely one of the biggest hurdles, you're right. Those legacy systems can be rigid, often proprietary, and notoriously tricky to connect with modern digital platforms. This often leads to data silos where information can't flow freely and long, painful implementation projects.
Yeah.
DBR77 tackles this pretty directly. First, it operates in a browser-based environment. That simplifies deployment massively because you don't need complex software installations on everyone's computer or major changes to the client's server infrastructure.
That helps.
Crucially, it uses a carefully designed open API that's an application programming interface. Think of it as a universal translator. This API allows DBR77 to communicate smoothly and seamlessly with those existing systems, your ERP managing business processes,
Yeah.
your MES controlling the shop floor, your WMS handling the warehouse.
So it bridges the gap.
It does. And to make it even smoother and minimize the time costs and the very real risk of disruption or downtime during integration, DBR77 provides active support from their own IT team. They work alongside the client on these integration projects, acting more like a partner in the transformation, not just selling software and walking away.
Okay, then there's the human element again. Always comes back to the people, doesn't it? Shifting the team's mindset. Moving from that old way, inspecting quality at the end of the line, to this new, proactive, in-process control way. That's a huge cultural change for many places, right? People get set in their ways.
It absolutely is a profound cultural shift, moving from that reactive, catch the bad ones at the end mentality, where quality is often seen as someone else's job, a final gate, to a proactive, build quality in at every step approach, where everyone feels responsible for quality as the product is being made. That requires a fundamental change in thinking, how people see their work and their role.
How do you encourage that shift?
Well, DBR77's approach ties back again to that human-centric design we mentioned.
Right.
Because the platform is designed to be intuitive, relatively easy to learn, usable after just a few hours of training for many functions, it significantly reduces the intimidation factor and the need for constant hand-holding from IT experts. It empowers the people on the floor.
Makes it less scary.
Exactly. This ease of use, the approachable interface, it really helps foster adoption. It encourages that crucial mindset shift towards continuous in-process quality thinking. When the tools are accessible, when employees feel empowered to use them, and when they start seeing the tangible benefits themselves, less rework means less stress, better output feels good. It helps turn potential resistance into active participation, even advocacy.
And then the unavoidable topic with any new tech, the cost, the infrastructure investment, needing significant cash up front for sensors, cameras, servers. That could be a massive barrier, especially for smaller or medium-sized companies.
Yes, that initial capital expenditure, the CapEx, can be really daunting. It's often a major hurdle in getting budget approval. DBR77 addresses this in a few ways. Firstly, as we mentioned, they offer their own hardware solutions, sensors, data collection systems. This simplifies procurement, as you're not trying to piece together components from 10 different vendors and hoping they work together. It ensures compatibility.
Streamlines things.
Right. And importantly, DBR77 offers a standard database for initial simulations. This means companies can actually start exploring the platform, running simulations, seeing potential benefits, even if they only have incomplete live data from their factory floor to begin with. This significantly lowers that initial investment barrier. You can start understanding the system's power and build a solid business case for a wider rollout before committing to deploying hundreds of sensors everywhere.
And the subscription model helps too, I guess.
Absolutely. Their subscription model avoids those huge upfront capital costs, shifting it to a more manageable operational expense, OpEx. This makes it much more accessible and scalable, particularly for companies that might not have deep pockets for large one-off investments.
Okay, building on that data point.
Yeah.
The effectiveness of the AI, the digital twin simulations, it all hinges on the quality of the data you feed it. Poor data in, unreliable results out, garbage in, garbage out.
Right.
How does DBR77 help ensure data quality, especially if a company's existing data isn't perfect?
Data quality is absolutely critical, yes. The garbage in, garbage out principle holds very true for AI and simulation, and it's a valid concern for many businesses starting this journey. As we touched on, DBR77 works to ensure foundational data quality partly by offering its own reliable hardware to sensors and providing support for robust data collection processes. This helps ensure the raw data coming in is accurate, consistent, and properly structured right from the source. And combined with that, as mentioned, is the standard database for initial simulations. This lets companies start using the digital twin and seeing value even if their own live operational data is still patchy or being improved. Now, obviously, a simulation based on incomplete or estimated data might have slightly less precision initially, but it's often more than sufficient to identify the major pain points, the biggest bottlenecks, the most obvious areas for improvement. It gives you a strong starting point. And as you deploy more sensors and refine data collection over time, the accuracy of the twin and the AI predictions just keeps improving. It allows for a phased approach, start seeing value quickly while progressively building data fidelity.
That makes sense. Now, something else we often hear about in the industrial world is the decision-making process itself. It can be incredibly slow for adopting new technology. Multiple stages, committees, pilot projects. It can take ages to get approval. How does DBR77 try to speed that up, cut through that inertia?
Yeah, those long multi-stage decision cycles are a well-known feature of many industrial clients. Lots of approvals needed, detailed ROI calculations demanded, extensive pilot phases required. It can definitely slow things down. DBR77 directly tackles this by being a strong advocate for pilot projects. They actively encourage clients to test the solutions first on a smaller, manageable scale, maybe one production line or one specific problem area.
Try before you buy,
So
essentially.
pretty much. This lets the client quickly verify the tangible effects, see the real benefits, calculate a localized ROI, all with minimal risk and commitment. This prove-it-first approach significantly lowers the perceived risk and can dramatically speed up the overall decision-making process.
Makes it easier to say yes.
Exactly. And the subscription model plays a big part here too. By avoiding those huge upfront capital investments that trigger the longest, most complex budget approval cycles, it makes it much easier for a manager or department head to get approval for a pilot project and start seeing results fast.
Okay, one last challenge area, building the partnerships. These complex digital transformations often require collaborating with lots of different tech providers, integrators, specialists. Putting that network together sounds like a huge job for any single manufacturing company.
It is a huge job, traditionally, but DBR77 has cleverly turned this challenge into one of its core strengths, a major value add for its users. The need to collaborate with various technology providers and system integrators is undeniable for effective digital transformation and automation. No single vendor can possibly provide every single piece of hardware, software, and expertise needed.
Right.
So what DBR77 has done is strategically build a massive online marketplace. This marketplace connects its manufacturing clients with an extensive curated network of over 800 technology providers and 600 system integrators.
Wow, that's a big network.
It is. It effectively creates this comprehensive one-stop shop ecosystem. It makes it incredibly easy for a DBR77 user to find the right specialist vendor for, say, a specific type of sensor, or the perfect robot integrator, or expert consulting services they might need for a project. This marketplace facilitates rapid access to specialized skills and technologies, significantly cutting down implementation costs and project delays. It's a huge benefit for the clients who get solutions faster, and also for the providers and integrators who gain access to a wide pool of potential customers.
So it really sounds like DBR77 has put a lot of thought into overcoming those common stumbling blocks, the things that often trip up these big digital transformation projects. They seem focused on making it as smooth and accessible as possible for companies wanting to step into this new manufacturing era.
Well, there's always more to learn, isn't there? And multiple perspectives always enrich understanding. But yes, DBR77's comprehensive approach certainly reflects a deep understanding of these common industry barriers. They seem to have developed practical, integrated solutions aimed at addressing each one, from the technical nuts and bolts of integration and hardware right through to helping foster that necessary shift in mindset within the workforce. They've clearly aimed to build an ecosystem, not just sell a piece of software.
Okay, so for our listeners who are hearing all this and thinking, right, I'm ready, I want to take action, I want to implement these kinds of solutions, what's a practical roadmap? How do you get started on this journey towards quality excellence using these insights? Could you maybe outline, say, 7 key steps for implementation?
Absolutely. The path to quality excellence is definitely systematic. It requires structure. So here's a potential 7-step roadmap based on what we've discussed. First, and this is foundational, you must begin by thoroughly analyzing the root causes of your current defects and customer complaints. Don't just look at the surface symptoms.
Big deal.
Exactly. Use tools like the 5 whys, fishbone diagrams, whatever works for you. You need to understand precisely why these problems are happening. Is it the raw materials, machine calibration drift, operator training, environmental factors? You can't fix it if you don't know the real cause.
Okay, step 1. Root cause analysis, what's next?
Step 2. Once you understand the why and the what of your defects, you need to pinpoint the most critical points in your production process. Where are quality issues most likely to originate? Or where do they have the biggest downstream impact? These are your high-risk zones, your quality bottlenecks. Focus your initial efforts here. You can't boil the ocean, so prioritize where you'll get the biggest bang for your buck first.
Makes sense. Identify the critical control points.
Yes.
Then, step 3 must be implementing the tech, right? Where do you start?
Right. Step 3 is to implement real-time monitoring of those crucial production conditions we talked about: temperature, humidity, pressure, vibration, etc., especially around those critical points you just identified. These environmental factors are often your earliest warnings. And then step 4, often done in parallel or soon after, is to strategically deploy intelligent vision systems at those sensitive, high-risk stages. This ensures any visible flaws, assembly mistakes, or dimensional errors are caught right away at or near the source, preventing them from contaminating the rest of the line.
So get the sensors and cameras in place at the key spots. Then you need to handle all that data.
Correct. Step 5 is absolutely crucial. Establish robust systems for collecting all this production data from the new sensors, the vision systems, but also integrating data from your existing MES, ERP, maybe quality databases, and analyzing it in real time. This is where comprehensive platforms like DBR77 really shine, bringing all those disparate data streams together into actionable insights, clear dashboards, and intelligent alerts. Don't just collect data, use it.
Okay, data collection and real-time analysis. What's step 6?
Step 6 is one that's easily overlooked but vital for success. Provide comprehensive, practical training for both your production teams and your quality assurance people. Technology is only a tool. Its effectiveness depends entirely on the people using it. A well-trained, engaged team that understands how the system works and why it benefits them is essential for successful adoption, effective use, and finding opportunities for ongoing improvement. Don't just dump tech on them, empower them.
Training, super important. And finally, step 7. It's not just set it and forget it, I assume.
Far from it. Step 7 is continuous optimization. This journey never really ends. Based on the data you're collecting, the insights from the analysis, maybe the recommendations from an AI assistant, and feedback from the team, you need to engage in ongoing refinement. Continuously optimize your process parameters, tweak your control limits, update your inspection routines. It's a perpetual cycle of improvement plan: do, check, act, driven by data, and focused on pushing quality levels ever higher.
That's a great roadmap. Analyze routes, find critical points, monitor conditions, use vision systems, collect and analyze data, train the team, and continuously optimize. It really boils down to this, doesn't it? Quality isn't just some cost center you have to manage or a box-ticking compliance exercise. It's actually a powerful differentiator. It's how you win customer loyalty, build trust, and ultimately gain an edge in the market. What's the ultimate payoff then? For companies that really commit to this holistic, technology-driven approach to quality excellence.
Critical thinking is so important today with all the information flying around, and this really is about making a strategic investment in quality. An investment designed to drive not just short-term efficiency gains, but long-term market leadership and sustainable growth. The ultimate win is multifaceted but profoundly impactful. Firstly, and perhaps most directly felt, higher product quality translates into dramatically fewer customer complaints and, consequently, a significantly higher level of customer loyalty. Happy customers stick around, they buy more, they become advocates for your brand. That's invaluable marketing right there.
And that loyalty, that satisfaction, surely builds credibility beyond just existing customers. Affects partners, too.
Absolutely. That's the second major payoff. Improved quality outcomes fundamentally boost your company's credibility and reputation. Not just with end users, but in the eyes of potential new clients, suppliers, investors, business partners. A strong reputation for consistent quality opens doors. It makes it easier to forge new partnerships, win bigger contracts, maybe enter new, more demanding markets, because people trust you can deliver. You become a preferred partner, not just another supplier.
And finally, the big picture view. Strengthening the brand itself and carving out a competitive advantage that's actually hard for rivals to copy quickly.
Precisely. That's the third strategic win. Consistently delivering superior quality strengthens your brand identity. Your name becomes synonymous with reliability, excellence, trust. This builds a powerful, sustainable, competitive advantage. It allows you to stand out clearly from competitors, maybe even command premium pricing for your superior quality, and potentially gain significant market share from rivals who are still stuck fighting fires with older, reactive quality approaches. It truly transforms quality from being perceived as a necessary evil or cost burden into your most potent strategic asset for winning in the marketplace.
What an incredible deep dive this has been into the world of product quality, defect reduction, and the tech transforming it all. It's crystal clear that while the costs of letting imperfections slip through can be immense, truly far-reaching, the tools we now have to combat those imperfections are becoming more powerful, more integrated, and crucially, more accessible than ever before. The intelligent combination of things like vision systems, the Internet of Things, artificial intelligence, and these comprehensive digital transformation platforms like DBR77, it's genuinely redefining what's possible in manufacturing. We seem to be heading towards an era where precision is the expected norm, not just a hopeful exception.
It really is a compelling journey, isn't it? From that old world of reactive damage control to this new potential for proactive, data-driven excellence. The future of manufacturing, it seems, isn't just about making more stuff, it's about making stuff better. More reliably, more sustainably, with greater efficiency than we thought possible just a few years ago. Ultimately, it's about building trust, one perfect product at a time.
So as we wrap up, here's a thought to take away. As technology allows us to get ever closer to near-perfect production, maybe achieving defect rates that were purely science fiction not long ago. Consider this. What new challenges might emerge for manufacturers beyond just making things flawless? Once zero defects is achievable, what's next? And how might our very understanding of quality evolve? Could it move beyond just the absence of flaws to encompass something more profound for the end user? Maybe things like hyper-personalization, guaranteed sustainability, or even the ethical transparency of the entire production process. How might that kind of shift redefine competition and reshape customer expectations in the years ahead? Something to ponder. We'll leave you with that thought. Thanks for joining us on The Deep Dive.